Hi, welcome to the SupernaNet.Connect connector for BMC Atrium. We're going to walk through a few of the use cases for CMDB synchronization with converged infrastructure. I'll walk through the configuration of this tool and walk through a few of the different use cases within Atrium to show you how it can be used. So what problems are we solving with this tool? Well, the main issue is synchronizing all the different components of a Vblock, both physical and logical, into your CMDB with the correct relationships, the right objects, and the right attributes. This tool simplifies the whole process from end to end. To step through some of the configuration before we get started, you click on the settings icon over here. So from this screen, you can add vblocks. You input the IP address of the Vision IO server and vCenter. You can also add multiple vCenters if required. BMC tab, you enter the IP address of your CMDB, credentials to log in, and the data set you want to synchronize to, which we'll show this in a little bit. Discovery, this just means every 30 minutes we're going to check for changes in the Vblock infrastructure and resynchronize it to the CMDB. This might be used, for instance, if you're adding blades. We'll pick up the addition of a blade or the removal of a blade in the Vblock and remove it from the CMDB as required. It also tracks VM creation, deletion, and movement. If a VM moves from one blade to another, every half an hour this connector will pick it up, detect the change, and make the correct changes in the CMDB. This way all of your relationships are all automated. There's no manual steps. Licensing tab and logs. So from here you can do debugging of the log. You can also watch the log live, kind of like a tail F command in Linux. So here's an example of the output. Let's close this. And we're here in the main screen. So after you've added your Vblock, here we're showing two different Vblocks that have been added. Vblock 300 and Vblock 700. In this case, these have been already added, inventory's been run, and we can now take a look at the different objects that are going to be synchronized. So we just browse through the compute domain. We can see here there's different chassis. Under the chassis, the different components. You'll notice over here on the right, there's a checkbox. This checkbox is designed to allow you to include or exclude a particular device from your CMDB. So as we go through the model, you'll notice by default, there's checkboxes already selected for you. Just scrolling through some of the objects here. And here's a second Vblock. If you select a component, you get a visual representation of where it exists. So as you change, it updates down here to show you where that object exists in the Vblock itself. So what do you have to do to get all the different objects, attributes, and relationships correctly set in your CMD? Well, the answer is basically nothing. Once you've added your Vblock to the system, we automatically select, based on BMC best practices, the objects that should be selected. In fact, we star them indicating these are mandatory. We do this at both the object level and the attribute level. There's actually no decisions to be made unless you want to override the defaults, and the defaults will give you a good working model of a Vblock at the physical and logical level and let you synchronize all these objects by default without any actions by the user. Once you've added the Vblock, you simply wait and it'll be synchronized to the CMDB dataset that you requested. If you do make changes in here, these changes get picked up on the next synchronization cycle, so I can either add objects by selecting the checkbox or I can deselect. As you make these selections down here, you get a count of the physical and virtual or logical CIs or configuration items that you're selecting. We also license based on CI synchronization, so you can control that by looking at this number down here. This tells you the next sync interval is 21 minutes from now. This list here is all the virtual machines on the selected Vblock. So you may or may not want to automatically select all your virtual machines to be synchronized. By default, this automatically happens. Every new VM that's detected gets automatically added. You can come in here and override that behavior by unselecting certain virtual machines that you don't want to manage in your CMDB. Both these options are on a per Vblock basis. Once you've configured everything, you can also, again, watch the log real time of the mapping process, or just check on the last time that the log was run. There's a lot of detail that's logged. At the end of this log, you'll see a summary of all the objects that were placed into the CMDB and the relationships between them. So what happens underneath the covers? Well, as the synchronization process runs, objects are inventoried, processed, and a schema mapping engine relates the fields and the objects to the appropriate class in the CMDB. This can all be customized with configuration files if you want to customize the attributes that are placed in different fields, or have custom strings, or combine multiple source attributes and map them into a target attribute. Now we've got this configured, we can see here the last sync was successful. This gives you a quick dashboard of the synchronization status of your different Vblocks. Once you're configured, there's no reason to be using this GUI. If you shut it down or log out, the process runs in the background as a service, and you can check on it by just simply opening up the GUI. So let's switch over to the BMC interface and see what we can do with our converged infrastructure objects now. So here we're logged into the BMC Remedy service dashboard. I've selected the asset console, and I've searched on product name Vblock 300. This is the 300 CI that we just inserted into the CMDB and promoted into the asset database. So here you can see some of the attributes that we'll just talk through. They get inserted into the CMDB automatically. The key one here is the serial number. The Vblock serial number is used throughout the object model, and we ensure that the serial number is attached to every physical and logical component in the Vblock. This makes it very easy to find all the related objects just by simply searching on serial number. The manufacturer of the component, the model and the version, and then the type of device and where it sits in the model. If we simply double click, we can drill in to this particular object and see that it's been completed with all the necessary information to manage this within the CMDB. We use this field called additional information. In here, we can insert attributes that don't have a natural home somewhere within the BMC model, and you can customize what type of name and value pairs that you want to insert into this field. This is available in every single object. The Relationships tab also lets us browse the Vblock in the asset database by simply selecting this tab and looking at either children of the current object or parents. In this case, we go up, we can see we've got the compute domain, storage domain, management domain, network domain, and racks. If I want to drill down into the storage domain, we can see here how we can browse through the different objects in the object model. Select parent. And so on. Let's go back up to the main asset console tree. So this is how you would manage your assets in the CMDB. All the normal things that you can do with any object in this view. You can go from deployed to any of these various states, received, in repair, down, end of life, and so on. Any other attributes can be completed from here as well. We'll now switch over to a different use case, show how we can simplify contract management as it relates to converged infrastructure. So we go to the contract management console. Here we can see we've entered a contract. This contract is of course with VCE and lets you support your Vblock through this maintenance contract. Normally you would create maintenance contracts for all the different components in a Vblock. In this case, because we've got a converged infrastructure model, all we have to do is attach this contract to the very top level Vblock object, and now we can manage all of the assets underneath it. So in this case, you would search for the CI, you would then attach the CI to this contract, and that's all you need to do. To show how you can do that through the asset management console, we'll just go back. Contracts tab, select maintenance. That's for creating one, but since we already have one, I see it down here, attached to and relate. Done. So now if I have an issue with a virtual machine, a blade, any of the components of the Vblock, all I need to do is trace the relationships up to the contract at the top of the Vblock, and now I have that one number to call, as opposed to attaching this contract or various contracts with various dates and times and states to all the different objects. So this of course is going to reduce the time and effort it takes to manage a Vblock and all of its assets in the CMDB. The next area I wanted to look at is the product catalog. The product catalog is a way that customers, I'm just going to do a quick search, can standardize on Vblock models and Vblock RCMs. So here we've actually inserted a new product. That product can now be attached to all the assets that are based on a Vblock 300EX. This of course means I can standardize on the product name within my CMDB and fully leverage the object model that's created by the connector using my product catalog. This of course can let me enforce my RCM releases and all the software maintenance and controls that you have with make and model and version and manufacturer. You can now simplify this process by attaching the product catalog entries to your Vblock entries. This used to be a difficult task with many different objects to manage. Now you can manage the entire Vblock as a single product. The last area I wanted to go through is business services. So the BMC Atrium console is a way to build relationships between CIs. I'll just go down to the data set we want to work with here. Just let me find it. One. Obviously, we have a lot of different data sets here from testing. Actually, we'll use the asset database. So this is a view of all the CIs that are in your asset database. Typically, customers would manage all of their assets in the asset management, but if they need to build relationships between their CIs, they're going to need to come into this interface to create business services and connect them to the different CIs that they are dependent upon to deliver that service. So if we go through an example, so from here I can see there's a management domain for a Vblock. I can expand. So here we've got a Vblock 700. And here you can see an example of how different objects are related to each other. These lines are actually CI objects that relate one object to another. They also allow fault propagation from one object to another to simulate failures in your environment and see what the impact will be. This is an example of a business service, a logical entity that's being used to deliver a service, and it's showing a relationship to the Vblock and the management domain. Underneath here we've got examples of virtual machines, and of course the relationships get more and more complicated. This of course is very labor intensive to create all these different relationships. Let's just look at how a Vblock simplifies this with the connector. I'm just going to look for the view. I know this may be hard to see, but what we have here is that very same Vblock 300 that we inserted into the CMDB. Here you can see the compute domain. Underneath it is the UCS. Underneath the UCS, we've got chassis. Under chassis, we've got blades and fabric interconnects. And then, of course, ultimately we have virtual machines. So over here, we've got the network domain. And you notice that all the lines that are drawn between these different objects, if we just edit one of them quickly, you can see here has impact and destination to source. These objects have to get created correctly to ensure that the object model performs as expected. So for instance, if I wanted to understand the impact of a failure to this component, we can simulate an impact. Those relationships are used to identify any neighboring adjacencies or objects that would be impacted by this device failing and becoming unavailable. Here we can see that this would impact the UCS chassis, the Vblock itself, and the entire compute domain would be impacted. The connector automatically creates and maintains all of these relationships, so there's no user actions required. If a relationship needs to be changed, the connector automatically makes the correct change in the CMDB, so that all your simulations are going to be accurate. If we wanted to create a business service that's dependent on this Vblock, simply right-click, create CI. We'll pick a business service, drag it over. So now we have a brand new service. This could be an archiving application. Now I want to instruct BMC to correctly relate it to my Vblock. If any of the components have an issue or under maintenance, and I want to understand the impact of my business service, I no longer need to create all these complex relationships down here. The connector automates this process completely, right down to the virtual machine. I only need to instruct BMC as to how this business service has a dependency on the Vblock. So if I just find our business service, I'm not sure where it went to. Oh, here it is. So now we can quickly edit the relationship to the Vblock and say if the Vblock has an issue, then this business service will be impacted from the source to destination, and we're done. Now I promote this into the asset database, and I can now build business service dashboards that monitor this business service based on the impact management of the Vblock CMDB information. So if we close this, I'll show what that would look like. Here's a separate tool that can be purchased from BMC called Service Level Management. This lets you create business service dashboards and manage the uptime availability of your infrastructure at the business service level. So here you can see that this particular business service running on a Vblock is in compliance with its agreement for availability. There's various different dashboards that you can create. You can be graphing availability of different business services. You can monitor your service targets and so on. All of these tools depend on the CMDB. They all depend on correct relationships in your CMDB. And the connector simplifies this process by automating the correct relationships and maintaining synchronization. So hopefully this walkthrough shows you the value of managing your converged infrastructure with the connector and how simple it is to now manage converged infrastructure in a CMDB application.